A modern cabinet door slides into place with a ghostly silence. To the eye, the wood simply follows its natural path, rotating on what appears to be a basic metal joint. The engineering reality is much more aggressive. A single industrial hinge, small enough to fit in your palm, is designed to suspend 50 kilograms of dead weight in midair, holding it perfectly level against the pull of gravity. Historically, this level of support required large exterior pivots bolted directly to the cabinet face. Creating a modern, hardwareless look meant engineers had to move these noisy, visible mechanisms into the interior of the cabinet box. Modern minimalism depends on shifting the mechanical burden away from visible exterior surfaces and into high-density components hidden inside the furniture. Every time a door is pulled open, the hinge experiences intense leverage. These constant physical forces attempt to pull the metal mounting screws straight out of the frame. Hardware like the Axomat 300 must withstand a brutal testing protocol to prove its durability. A door is loaded with a 72-kilogram weight, swung open and dropped. To pass, the vertical sag of the door cannot exceed 1/32 of an inch. The endurance requirement is even steeper. The hinge must survive being slammed open and shut 100,000 times. This simulates 2 decades of consistent human use. A hinge functions as a silent shock absorber, spending decades managing violent kinetic energy to protect the integrity of the cabinet. The hidden metal cup and arm mechanism reveals how a cabinet door slows itself down. This soft close motion is achieved through a miniaturized hydraulic damping system. As the hinge closes, a small piston compresses fluid, creating the resistance necessary to catch the door and bleed off its momentum. This system engages at a specific tipping point. Between 10 and 20 degrees from the frame, a hidden spring takes over, pulling the door shut while the hydraulics keep the motion smooth. To prevent the hydraulics from freezing or thinning out in different climates, high-end models utilize thermal stabilization. This ensures the fluid maintains its exact viscosity, whether it's in a cold room or a high-temperature kitchen. Calibrated temperature-resistant fluid dynamics transform what would be a violent slam into a controlled, silent rest. Modern frameless cabinets leave no room for error. The heavy wood panels must sit flush against the frame, requiring alignment that persists over years of use. Engineers account for this by integrating eccentric cams, small discs that allow for 6-way micro-adjustments. By turning a screw, the entire mechanism shifts along the X, Y, or Z axis with millimeter precision. This precision allows for the full overlay look. The door covers the cabinet sides completely, but it maintains a microscopically calculated reveal gap so it never grinds against the frame during its pivot. These advanced kinematics are now so efficient that installers can suspend larger, heavier doors using fewer hinges than were required for older, lighter designs. The perfect flush geometry of a modern kitchen is a carefully maintained illusion, supported by a network of hidden micro-adjustments. Beyond the kitchen, hinges move into high-stakes industrial environments, where mechanical failure leads to severe safety risks. In these settings, hardware is often engineered to intentionally fail. Systems like the Senso hinge are designed to unsnap their middle joints under sudden pressure, preventing the mechanism from crushing a user's fingers. Other industrial models feature quick-release pins, allowing technicians to instantly remove a heavy door from a live electrical panel without unscrewing any hardware. In high-risk scenarios, the ultimate engineering achievement is the ability of the hinge to instantly and safely dismantle itself. Sleek, hardware-less design defines the appearance of modern luxury kitchens, surgical rooms, and server farms. This visual cleanliness is a direct result of hardware density. To make the exterior look empty, the interior of the hinge must be packed with more sophisticated components. The visual simplicity of contemporary design relies on the increased sophistication of the hardware we hide. The simple metal joints of the past have been replaced by thermally stabilized, micro-adjustable machines capable of resisting immense physical stress. Pushing a door shut activates a calibrated high-tech engine, executing a series of mechanical commands in the blink of an eye. The most critical engineering in our daily lives is often the machinery we were designed never to see.